Oh, hello there. Just an average Tuesday. Nothing special going on, not like I would highlight anything in particular. Oh, what's this? JWST spots giant black holes all over the early universe. Well, you all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So I noticed a couple of different things, and I think Anton had did something on this, and I had started to go back and look through some other things. And I was going to do it as a series of separate videos because just the rough, extremely high level estimate, it's like one of these things. It's like black holes are everywhere in the early universe. It's like whoa. And then you see something else. It's like active galactic nuclei are far fewer than scientists expecting. You're like, whoa, you're like, oh, they're talking about black holes. It's like these may fall within the category of black hole, but one may be gigantic, but one may not necessarily be active. At first, I thought this may have just been contradictory research or something, because one came out a little bit after, and I'm like, wait a second. I'm going to take the words that come out of my mouth seriously at times. Then there may actually be a easier explanation for this. But let's not bury the lead. Let's jump right into some of these articles. Of course, links are in the doobly-doo below. JWST spots giant black holes all over the early universe. Giant black holes are supposed to be, I believe that's big players in the early cosmic story. But recently, James Webb Space Telescope observations are finding an unexpected abundance of the beasts. Ooh, look at all of them here, there, everywhere. And then apparently mixed in with there, you'll have like those kaiju stars like Godzilla and Mothra and everything. But years before she was even sure the James Webb Space Telescope would successfully launch, Christina Ehlers started planning a conference for her. I feel like I did this before. I feel like I actually covered this exactly. Basically, long story short, again, links in the doobly-doo. They seem to keep on finding more and more because we have better resolution. I mean, you've got that big, shiny 18-meter array of mirrors and everything. Don't get me wrong, Hubble's still doing a lot of work. Kind of is one of the goats, or it's at least an OG. But we keep on discovering more and more. And that's fascinating. And I mean, is this really a surprise? Okay, some of the models, maybe we didn't think there were going to be as many, but especially with the pulsar timing array and everything. Am I sharing the right thing? Nope, I am sharing the. Oh, I apologize. Let me share the window. Type of. There we go. We won't want to deny people the ability to look at the science. Okay. So black holes over there. So as we know from our friends at NANOGrav, from the release about a month or so ago, according to the pulsar timing array, what the heck is that? Basically, they got a whole bunch of, I believe, radio telescopes. I believe that's primarily what we're using. Maybe some X-ray. But basically, they're measuring the signals because these pulsars, they're spinning around. They're massive black holes, and they're spinning incredibly fast. Some of them even millisecond range. At one point, they were more accurate than atomic clocks, and I think back in 2012, we made better atomic clocks. I think that's fascinating for something that's, I don't know, at times like light years and light years away, mostly within the galaxy, to my knowledge. But basically, by analyzing that and noticing some of the disruptions there, and after about 15 years of data to parse out like all as much noise as they can, what they had 3 or was that 5 sigma? It was pretty dang high. I want to say it was 5 sigma, but I saw somebody the other day that I think worked on it, and I believe they only said it was 3 sigma. So we'll go with the lower bounds on that. But essentially, that is mostly being attributed to the hum of potentially colliding supermassive black holes. That's what a lot of folks are attributing it to. Are we seeing that yet? Don't know. Yeah, it could be, maybe. Yeah, we have to look through all the data. We got plenty of data we need to go through and continue to collect. But what may also be going on here? So, what may be potentially added, because essentially, even according to Professor Sean Carroll, you wave your hand, you're creating gravitational waves. They're very tiny waves, but also here's another article is from isdocs.org. James Webb Space Telescope survey reveals fewer supermassive black holes than presumed. What? That that seems to be completely contradictory. Reveals fewer supermassive black holes. So it's giant black holes. Wait a second. You go down to the bottom to get the date, and this was, I think, the 14th of this month. This was August 14th. This one. So August 23rd. There's a lot changed in 9 days. But when you actually parse into it, it actually starts to make more sense. Did I cover this too? Maybe. University of Kansas. Survey of a swath of cosmos using the James Webb Space Telescope has revealed active galactic nuclei. AGN. Basically the ones that are what we believe to be feeding heavily, growing. Basically things that, according to many scientists, to the best of my knowledge and recollection, believe should be pretty busy building up into larger galaxies, but that doesn't seem to be the case. And that's interesting. Supermassive black holes that are rapidly increasing size are rarer than many astronomers had assumed previously. The findings made at the WST's mid-infrared instrument MIRI suggest our universe may be a bit more stable than was supposed. The work also gives insights into observations of faint galaxies, their properties, and the challenges in identifying AGN. So they're going through the Sears study, which is basically, I think, James Webb's version of kind of like the Hubble Deep Field, I believe. The work headed by Alison Kirkpatrick, guest on Into the Impossible podcast. Maybe future on this one. Assistant professor of physical astronomy at Kansas University, focused on a long-studied zone of the cosmos dubbed the extended Groth Strip. Not Goth Strip, Groth Strip. Located between Ursa Major and Abuth constellations, but previous examinations of the area relied on less powerful generation of space telescopes. But hey, Dan, thank you for joining, my friend. We're just going over some black holes and the early universe, and it's interesting. It's very interesting. It's an exciting time to be into cosmology, I claim. But where are we? All right, our observations were taken in last June and December, and we're aiming to characterize how galaxies looked during the heyday of star formation in the universe, Kirkpatrick said. It was a look back in time of 7 to 10 billion years in the past. We used the mid-infrared instruments on the James Webb Space Telescope to look at dust in galaxies that are existing 10 billion years in the past. And that dust can hide ongoing star formation. It can hide growing supermassive black holes. So I carried out the first survey to search for these lurking supermassive black holes at the center of these galaxies. Well, every galaxy features a supermassive black hole at the middle, to the best of our knowledge. AGN, active galactic nuclei, are more spectacular upheavals, actively drawing in gases and showing a luminosity absent from typical black holes. Kirkpatrick and fellow astrophysicists anticipate that the higher resolution JWST survey would locate many more AGNs than a previous survey conducted with the Spitzer Space Telescope. However, even with MIRI's boost in power and sensitivity, few additional AGN were found in the new survey. That's quite interesting. We're seeing all these giant black holes in the universe. They're finding them all over the place. Shouldn't more be active? It seems to stray from the current cosmological paradigm if we're going to find these things and say, all right, more should be active. Why? They need to grow and everything, but why are they not so active? The plot thickens. The results look completely different from what I had expected. Leading to my first major surprise, Kirkpatrick said. One significant revelation was the scarcity of rapidly growing supermassive black holes. This finding was prompting questions about the whereabouts of these objects. As it turns out, these black holes are likely growing at a slower pace than previously believed, which is intriguing, considering the galaxies I examine resemble our Milky Way from the past. Earlier observations using Spitzer only allowed us to study the brightest and most massive galaxies with rapidly growing supermassive black holes, making them easy to detect. So it's I can neither confirm nor deny that. And all I know is my just personal opinion. This maybe turns some folks off. The more I learn about science, the more I believe in God. I said it. My opinion. Um, another surprising outcome was a lack of dust in these galaxies. The Kansas University astronomer. Hmm. Hold on. The study's findings that these black holes are not rapidly absorbing limited material, and perhaps not significantly impacting their host galaxy, she said. The discovery opens up a whole new perspective on black hole growth, since our current understanding is largely based on the most massive black holes in the biggest galaxies, which have significant effects on their hosts. But the smaller black holes in these galaxies likely do not. Huh. That's quite interesting. That's basically the article right there. So they're doing her current paper has about 400 galaxies. So we're getting more and more data. But okay, where's my rampant speculation? Oh yeah, I also have an article from Nature. I was going to go more into it. I paid the money to get the Nature thing, and I need to contact customer support. Basically, it's the same thing as the first thing. JWST spies more black holes than astronomers predicted. Okay. So what's the big claim here? How can we solve this? Okay. Now again, full disclosure. I am totally biased. I am not a professionally trained physicist or astronomer. I'm a dude on the internet. And that's been blessed enough to talk and listen to a lot of really smart folks out there. Some of whom may be watching now, or temporally in the future. But the claim is, well, number one, if universe, as we know it, our realm of persistence, if T is greater than 14 billion, I believe Professor Gupta up in was it the University of Ottawa, uh, he read the paper about that. I mean, it's about twice as old, around 27 billion years. Okay, there are assumptions there, but we have assumptions too. A lot of folks aren't quite convinced yet. That's fine. I'm going to claim that it's probably older than 14 billion years. It would explain a lot, but also my personal claim is based upon the models. And again, this is from the physics monastery and stuff based upon my interpretation of the work that's been going on. I'm thinking the 10 to 26 meters that we see in the observable universe per se, it's a lot smaller than what's probably out there. The claim is our universe, as far as if you were to spatially try to measure it, it's about in the magnitude of about 10 to the 32 meters. So you literally like replace the Planck temperature with meters. Replace Kelvin with meters, and I think that's a radius. Again, crazy claim. That means universe as we know it would have positive curvature, number one. So if you keep on going, you're eventually going to kind of curve around, kind of like in the game of asteroids and stuff. You just kind of loop around. Why? Claim is it's an N hypersphere of maximal volume, balanced on the minimal, non-compact, orientable 3 manifold, the Giesecke constant, which by itself may not persist when you get a double cover. And you get the hyperbolic figure 8 knots complement. The claim is that's essentially the cinch of reality. Completely out there claim, but there seems to be some math to back it up. I still need to go through all of it. I've been doing work, doing this and that. Maybe I'll get a new computer that I need to still set up. So we're going to start to computate all that, and we'll have the notebooks out and everything. And, people can do what they want. Nobody's going to believe me. I'm just a dude on the internet. But if the observations continue, and they continue, and it looks like, and again, some people may claim, and I'm going off into even more rampant speculation here, is Some folks say, well, the multiverse, we're just a bubble universe. What's a bubble universe? Well, we used to, I believe even Einstein at one point thought, well, the Milky Way is basically it. Well, that's basically what we see. So, I mean, you can only go based upon the data you have, what you know at the time. And there's some very strong claims there that I'm making. Sure, universe, probably older than 14 billion years. Relative to us, probably only is 14 billion years to our observations. Why? We rewrite general relativity. Go back to a point. In this model, it's basically kind of like an eternal fountain. Everything is recycling. Everything is in balance. Coincidentally, a perpetual motion machine is not possible, with the exception of, I believe, the Cardano machine of the third type. You can't increase the energy. But if everything was perfectly enclosed, so to speak, it may persist. Is there a perfect machine out there? I don't know. If there was, well, I can only imagine. But that's all I got for right now. Hopefully, somebody out there finds this useful, maybe takes an idea that is very underdeveloped and can develop it more. Why? I'd love to find out what's actually going on. So that's all I got for right now. Peace out, everybody. Take care of yourselves. It's a wacky and wild world out there, but I think the best is on the horizon. Drink up, me hearties. Yo ho!